The topic of this video is solving equations by factoring. We're going to be using what's called the zero factor property. So look at the top of your notes and you'll see a box that has the definition. It says if two numbers have a product of zero, then at least one of the numbers must be zero. In other words, let's say I had a square times a triangle, and the product of that multiplication was zero. Well, the only way to get a zero answer in multiplication is if one or both of the numbers are zero. So either the square would have to be zero or the triangle would have to be zero. We say that algebraically this way: if AB, meaning A times B, equals zero, then either A equals zero or B equals zero. So let's look at how we use that to solve an equation. So what we have here, x plus 6 times 2x minus 3 equals 0, is an equation that has already been factored. The two factors are x plus 6 and 2x minus 3. So it's the same thing as if, let me write this a little bit bigger so it will fit. Using my square and triangle analogy, it's as if the square is the x plus 6 and the triangle is the 2x minus 3, and multiplied together they equal 0. So what the zero factor property tells us is if you have an equation and it's already equal to 0 and it's already been factored, then you apply the property of 0, which says either x plus 6 equals 0 or 2x minus 3 equals 0. And then at that point you have two small equations to solve. I solve this one by subtracting a 6. Here I'm going to add a 3, 2x equals 3, and divide by 2, and I get two solutions. Either x is negative 6 or x is positive 3/2. So when solving a quadratic equation, the first thing that you're going to notice is that we get two answers. Two different answers. It's possible the answers could be the same. You may see one like that, but generally you get two different answers, and that comes from the two different factors that are set equal to 0 separately. Now, in most scenarios, the equation will not already be factored for you the way that it was done in example 1. So let's look at example 2a. I have an equation here, 2x squared plus 3x equals 2. I want to use the zero factor property to solve that equation. So the z tells me get it equal to 0. So the letters of that property tell you what to do. Get it equal to 0. Well, it's not equal to 0, but I can make it equal to 0 by subtracting a 2 and getting 2x squared plus 3x minus 2 equals 0. So the first step has been done. The F stands for factor. Now I have to factor. This is why it was important that you know how to factor for the rest of this course. So I'm looking at a trinomial that does not start with a 1, so I believe it to be the long process. So 2 times negative 2 is negative 4. I need factors that add up to positive 3. I believe that is positive 4 and negative 1. So I'm going to break down this term into these two pieces. So plus 4x minus 1x, and now bring down the last. And now we have this equals 0 tagged on to the end. We won't worry about that yet. 1, 2, 3, 4 tells me to group. There's a 1 there. I have a negative in between, and I know from another video that I need to make a correction on my last term when that happens by changing its sign. Now I factor out the GCF of the first binomial and write what's left. Bring down that minus sign. The GCF of 1x plus 2 is just a 1, and you have to write that. X plus 2. Now I have x plus 2, that's my common factor, and 2x minus 1. Now, if we were just factoring, we would be finished, but we're not. We are using zero factor property. So we finished factoring. We now have to apply the property the same way we did in example 1 when we had two factors equal to 0. So we say either x plus 2 equals 0, in which case I solve and I get x equals negative 2, or, kind of running out of space here, this one, or 2x minus 1 equals 0. Here I'm going to add a 1, 2x equals 1, I'm going to divide by 2, and I get my other solution, which is 1/2. So I have x equals negative 2 or x equals 1/2. And I arrived at that by factoring and then setting each factor equal to 0 separately. Let's look at this next one. I'm going to write down my acronym here to help me remember what to do. I need to get it equal to 0. Well, it already is. I need to factor it. Well, to factor it, I notice that it has a 4 in the front, so it's a long process. I need factors of positive 4 that combine to make negative 4, negative 2 and negative 2. So I bring down the first, I break down the second into those two pieces, I bring down the last. Now I'm going to group. Once again, I have a negative in between, so we're going to make a correction on that last term, like that. Factor out the GCF of the first binomial. Write what's left. Bring down your minus. The GCF here is a 1, 2x minus 1. You can see that they match, so I have 2x minus 1 times, notice what's left on the outside, another 2x minus 1. So now I'm supposed to apply the property by setting each factor equal to 0. But since they're the same, there is no reason to write that and do it twice. You're going to get the same answer twice. So I'm going to add a 1. 2x equals 1. I'm going to divide by 2, and I get x equals 1/2. Now, I only got one answer, but in reality, I had two factors. It's just that they were the same. So if I had set them each equal to 0, I would have gotten x equals 1/2, comma, or 1/2. No need to write that twice. So in the case where your factors are the same, you're only going to get one answer for x. Let's try another one. Again, let's use that acronym. Scoot it over so you can see it to tell us what to do. First, get it equal to 0. That's been done. Next, we need to factor. I have a difference. This is a perfect square, but this is not. So the only other thing it can be is factor out a GCF. So I'm going to factor out 4x. That's what they have in common. We're left with x minus 5 equals 0. So I have factored. I now need to apply the property, which means set each factor equal to 0. And I do have two factors. Even though the first one isn't in parentheses, it's still a factor. So either 4x equals 0 or x minus 5 equals 0. Here I divide by 4 to solve, and I get x equals 0. Or here I add a 5 to solve, and I get x equals 5. So there are my two answers. And by the way, if you want to show it as a set, it would be the set of 0, 5, like that. All right, the last one, 3x squared minus 108 equals 0. 0 factor property. It's already equal to 0. I'm going to factor by first factoring out a GCF. 3 goes into both of those, and I have x squared minus 36 equals 0. Now you may think we're finished factoring, but we're not, because what is left in parentheses is an example of a difference of two squares. So I'm going to bring down that 3. Now I have to factor what's in parentheses, difference of two squares. XX, 1 is a plus, 1 is a minus, 6 equals 0. Now I'm ready to apply the property by setting each factor equal to 0. But what do we do with that 3? It's very easy. I'm going to divide both sides by 3 to get rid of it. So I've got x plus 6 times x minus 6 equals 0 divided by 3 is 0. Now I set each factor equal to 0, and I solve each of those little equations, getting x equals negative 6 or x equals positive 6. And again, I have my two answers in solving my equation.